So you've requested a deep dive into Pierre de Fermat.
Ah, yes, Fermat.
It's a fascinating journey, and you want to understand why he's considered such an important figure.
Even centuries later.
Right. And we've got some excerpts from a biography about him.
To help guide us.
Exactly.
Ah.
And, while many know him for that infamous last theorem,
Of course.
Fermat's contributions to math, well, they go way beyond that one puzzle.
Oh, absolutely. His impact is felt across so many different areas. It's remarkable.
Really?
Yeah, number theory, analytic geometry,
Wow.
calculus, and even probability.
It's like he had this knack for uncovering hidden connections and patterns.
It's a great way to put it.
So let's start with that last theorem, since it's what usually makes headlines.
Sure.
It essentially states that the equation x to the n plus y to the n equals z to the n
Right.
has no whole number solutions when n is greater than 2.
That's the one.
The thing is, it took over 350 years and some serious mathematical firepower to actually prove it.
Yeah, what makes it so compelling is that Fermat claimed to have a proof
Oh,
that said it was too long to fit in the margin of the book where he wrote this note.
Oh, come on.
Now, the book suggests that given the mathematical tools available in the 17th century,
Yeah.
it's highly unlikely he had a complete proof.
So he was just like messing with everybody.
Well, it makes his claim even more intriguing, doesn't it?
I can imagine the frustration for mathematicians over the centuries.
Oh, I'm sure.
This seemingly simple statement,
Yeah.
it became one of the longest-standing unsolved problems in mathematics.
It really highlights the allure of Fermat's work and the determination of mathematicians
I see.
to conquer such a formidable challenge. It wasn't until 1993 that Andrew Wiles finally presented a proof.
Oh, wow.
And even that had a near miss,
What do you mean?
an error that required another year of work to correct.
Wow, so close. The book describes it perfectly. One of the most difficult problems in the world, also one of the oldest unsolved, finally fell before the systematic attack of a brilliant mathematician who had worked alone for more than 5 years.
You can just imagine the pressure.
I know. And the intellectual stamina to dedicate such a significant portion of your life to a single problem, that's remarkable.
It is. It's a testament to the power of Fermat's legacy, his enduring impact.
So the last theorem might be his claim to fame.
Right.
But Fermat was up to so much more.
Oh, yeah.
He was especially fascinated by number properties, particularly prime numbers.
This is where we see Fermat's true genius emerge.
Okay.
He wasn't simply interested in solving specific problems, he was seeking general rules and patterns in the world of numbers, essentially establishing the foundation for modern number theory.
Wow, so he was thinking big picture.
Exactly.
He was particularly interested in perfect numbers, those that are equal to the sum of their divisors. Fermat developed these innovative methods to analyze them, expanding upon the work of the ancient Greeks.
It seems like he was always looking for the underlying structure and relationships within numbers.
Fascinating.
And there's this captivating anecdote about amicable numbers in the book.
Amicable numbers.
Yeah, during the Middle Ages, it was believed that eating bread inscribed with these numbers would create a lifelong bond between people.
You're kidding.
It's a reminder of how math has often been intertwined with cultural beliefs.
That's so interesting. Now, while the last theorem gets all the attention, it's Fermat's little theorem that had a truly massive impact.
Absolutely. It might not be as well known, but...
It's really important.
Oh, this theorem was like Fermat's secret weapon for unlocking the mysteries of prime numbers.
Centuries before computers even existed.
That's right.
He could actually use it to quickly test whether large numbers were prime, which is incredible.
I know, especially when you think about the limited tools he had at his disposal.
It's mind-blowing.
Well, the book even describes a story where, in a letter, Fermat effortlessly factors a huge number
Really?
for his colleague Morin Mersenne, demonstrating his mastery of number theory.
How big are we talking?
Oh, it was massive. And here's where it gets really impactful. This same theorem underpins the cryptography that secures our online world today.
It's mind-boggling to think that Fermat's work from the 1600s is now essential for things like online banking and secure communications. What a legacy.
It highlights the unexpected and far-reaching consequences that seemingly abstract mathematical concepts can have on the world.
Now, at the same time that he was revolutionizing number theory, Fermat was also co-inventing analytic geometry.
Oh, yes.
But he had a rival in this endeavor.
René Descartes.
It truly was a clash of titans.
It was. Analytic geometry connects algebra and geometry, allowing curves to be described by equations.
A major leap forward.
A huge leap.
And wouldn't you know it, Both Fermat and Descartes made this discovery independently.
That's right.
But, as you know, it's Descartes who generally gets the credit.
Because Cartesian coordinates have a nice ring to them.
Yeah, rolls right off the tongue.
However, the book reveals a surprising detail. Fermat actually published his work first.
He did.
He did. The challenge was his notation, influenced by his mentor, Vieta. It wasn't as clear or concise as Descartes' approach.
Ah, the classic tale of being overshadowed because you didn't quite nail the presentation.
That's it exactly.
So how did Fermat react to playing second fiddle to Descartes?
Well, the book describes their relationship as a heated intellectual rivalry.
Oh, I bet.
Initially, Descartes mocked Fermat's work.
Oh, no.
But he was quickly silenced when Fermat correctly solved a challenging tangent problem that had baffled Descartes.
Ouch. That's got to feel good. Proving your rival wrong in such a decisive way.
I would say so.
It seems like Fermat had a knack for proving himself even if he didn't always get the initial recognition.
He did.
But even with his incredible insights, he wasn't immune to mathematical near misses.
That's true.
One area where this is evident is his work on calculus.
It's true. Fermat developed methods for finding tangents to curves and calculating areas under them, core concepts of calculus. He accomplished this using his adequality method.
Adequality.
Yeah, essentially involved manipulating equations to determine maximums, minimums, and tangent points.
So he had the building blocks, but what was missing?
The key insight that Fermat missed was the fundamental theorem of calculus,
Oh, okay.
which elegantly connects these seemingly disparate concepts. This pivotal breakthrough would later be formalized by Newton and Leibniz.
That makes you wonder, if Fermat had taken a step back and seen the bigger picture, could he have been the father of calculus as well?
It's a tantalizing thought.
It is.
But perhaps his laser focus on individual problems, while leading to remarkable insights, also prevented him from grasping the unifying principle that underpins calculus.
It seems like for all his genius, Fermat had a blind spot when it came to seeing the forest for the trees, at least in the case of calculus.
It would seem that way.
But speaking of surprising turns, who knew that Fermat would end up dabbling in probability?
Well, after a period of relative mathematical silence, Fermat reemerges in 1654, engaged in a fascinating correspondence with Blaise Pascal.
Oh, wow.
The topic of their exchange, gambling problems.
So the same mind that grappled with some of the most complex mathematical problems was also trying to figure out the odds of winning a card game. That's quite a contrast.
Well, it speaks to the breadth of Fermat's intellectual curiosity and his ability to apply his mathematical thinking to diverse problems. This seemingly casual pursuit actually led to the birth of probability theory.
Wow, this is where things get really interesting. Tell me more about this collaboration with Pascal.
Well, they were trying to solve what was known as the problem of points.
The problem of points.
How to fairly divide the winnings in an unfinished game. Fermat developed an elegant approach based on counting possible outcomes, which was simpler than Pascal's more algebraic methods.
It seems that even mathematical geniuses appreciate the practical applications of math in everyday situations. This unlikely partnership between Fermat and Pascal, it demonstrates how groundbreaking ideas can emerge from unexpected collaborations.
And how even seemingly trivial problems can spark significant intellectual breakthroughs.
That's so cool. Now, while this work on probability was a departure for Fermat, he wasn't quite done with his intellectual duels.
No, he wasn't.
His final act takes us back to a familiar rival, Descartes. And this time, the battleground is optics.
Oh, this should be good. It seems Fermat just couldn't resist a good intellectual sparring match, even in the later stages of his life. What was the source of contention this time? Descartes had proposed a theory of refraction, describing how light bends when it passes from one medium to another. But Fermat had his doubts. This is where his principle of least time comes into play. He
proposed that light always travels the path that takes the least amount of time.
Wait a minute, isn't that getting awfully close to the principles of calculus?
Interesting point.
Which he supposedly missed. It sounds like he was circling back to ideas that had previously eluded him.
You're right to point that out. It's another instance where Fermat was right on the verge of a major breakthrough.
Really?
He used his adequality method, a precursor to calculus, to derive Snell's law of refraction from his principle.
It's fascinating how Fermat's work keeps intersecting with these major mathematical developments, even if he doesn't always make the final connections himself. It speaks to his intuition and his ability to be ahead of his time. So, what was the ultimate outcome of his final duel with Descartes?
Fermat's principle of least time, now known as Fermat's principle, had profound implications for our understanding of optics and later influenced other areas of physics.
Wow.
While the rivalry with Descartes continued, Fermat's principle ultimately provided a more accurate and elegant explanation for the behavior of light. It's a fitting final chapter for a mathematician who spent his life challenging conventions and pushing the boundaries of knowledge. He may have craved recognition from his peers, but his legacy ultimately transcended the limitations of his time. And on that note, we'll take a quick break and return to explore the lasting impact of Fermat's work and what lessons we can draw from his remarkable life.
Welcome back to our deep dive into the world of Pierre de Fermat. Before the break, we were discussing his fascinating work on the nature of light.
Yeah, his principle of least time.
Right, and how it solidified his place in the history of optics.
It's amazing to think that one person could have such a profound impact on so many different areas.
Of math and science, yeah.
It really speaks to the power of a curious mind
It does.
and the importance of approaching problems from multiple angles.
Multiple angles, for sure.
Yeah.
Now, let's shift gears back to Fermat's work on number theory,
Okay.
where we can really see his genius shine through.
You mentioned earlier that he was particularly fascinated by prime numbers.
Yes.
Can you unpack that a bit more for us?
So, prime numbers, right? They're whole numbers greater than 1 that are only divisible by 1 in themselves.
Okay.
They're the building blocks of all other whole numbers.
The building blocks. Okay.
And Fermat was captivated by their properties and how they behave,
I see.
especially a special type called Mersenne primes.
Mersenne primes, why were those so intriguing to him?
Well, it turns out they're closely related to perfect numbers,
Oh, right.
which we discussed earlier, those numbers that are equal to the sum of their divisors.
Yes. I remember that 6 is a perfect number.
Because
1 plus 2 plus 3 equals 6. So what's the connection between these Mersenne primes and perfect numbers?
Well, it was Euclid, the ancient Greek mathematician,
Okay.
who first discovered that if you have a Mersenne prime, you can use it to create a perfect number.
How does that work?
You simply take that Mersenne prime and multiply it by 2 raised to the power of 1 less than the prime's exponent. So, for example, the Mersenne prime 3, which can be written as 2 squared minus 1, can be used to generate the perfect number 6. 3 multiplied by 2 to the power of 1.
So Fermat was using these Mersenne primes as a sort of like blueprint for finding perfect numbers.
That's a great way to put it. While Fermat didn't prove the direct connection, that was later accomplished by Euler.
Oh, okay.
He was deeply interested in this relationship and devoted significant time to exploring it.
It seems like Fermat and his fellow mathematicians were constantly challenging each other with these number puzzles.
You're right. Their correspondence is filled with back and forth discussions about new discoveries and unsolved problems.
Really?
In fact, there's a famous story about Fermat factoring a massive number for his friend and colleague, Marin Mersenne.
Oh, yes. I read about that in the book.
It was a number with 12 digits.
How could he possibly factor something that large without a calculator?
Let alone a computer.
Right.
It's a testament to Fermat's mastery of number theory and his ability to utilize clever techniques. Remember his little theorem?
Yeah.
It provided a powerful shortcut for testing the divisibility of large numbers.
It was like a secret weapon for unlocking prime number mysteries.
Exactly. And to think that this theorem is now used to secure our online transactions.
It's a wonderful example of how abstract mathematical ideas can have a real-world impact centuries later.
It really is.
Fermat's story is truly inspiring.
It is.
He was a lawyer by profession, but his passion for mathematics clearly drove his groundbreaking discoveries.
And his legacy continues to inspire mathematicians today. However, you know, it's important to acknowledge that Fermat's approach wasn't without its drawbacks. His secrecy and reluctance to fully document his methods sometimes created barriers to understanding and collaboration.
You mean his habit of not always sharing his proofs?
Exactly. He would often simply state his results without providing the steps he took to arrive at them. This made it difficult for others to fully grasp his work and build upon it.
It's like he was leaving these tantalizing clues, but not revealing the whole picture.
Like a puzzle.
I guess even geniuses have their quirks.
Indeed. And this lack of transparency sometimes led to confusion and even misattribution.
Misattribution, what do you mean?
Well, for example, Fermat developed a technique for solving a particular type of equation,
Okay.
which is now known as Pill's equation.
Hold on. Why is it named after someone else if Fermat was the one who solved it?
Well, in typical Fermat fashion, he never formally published his solution.
Oh, no.
It circulated through letters and manuscripts before eventually landing in the hands of John Wallis, an English mathematician.
And Wallace mistakenly attributed the solution to John Pell.
It seems that Pell likely had little to do with the original solution.
But the name stuck.
The name stuck, unfortunately.
So Fermat, yet again, missed out on the credit he deserved.
It seems so.
It's a shame that his secretive nature sometimes obscured his brilliance.
It's a cautionary tale for all of us. While individual breakthroughs are important,
Yeah.
collaboration and clear communication are essential for the advancement of knowledge.
It makes you wonder how Fermat's legacy might have been different if he had embraced a more open approach.
Right. Would he have received more recognition during his lifetime?
Would his work have had an even greater impact? We can only speculate.
It's impossible to know for sure, but it's certainly a fascinating thought experiment. Despite these missed opportunities, Fermat's contributions are undeniable. He was a true pioneer who reshaped the landscape of mathematics and paved the way for future generations.
So we've discussed his significant achievements in number theory, his rivalry with Descartes in analytic geometry, and his near miss with the fundamental theorem of calculus. We've also touched upon his foray into probability theory and his final duel with Descartes in the realm of optics.
Quite a journey.
It was quite an impressive body of work for someone who considered math a hobby.
It really is. Fermat's unwavering curiosity and his passion for problem solving led him to make, significant contributions to numerous fields. And while his last theorem often takes center stage, it's important to remember that his legacy extends far beyond that one problem.
Now that we have a more complete picture of Fermat's work,
Yes.
I'm eager to delve deeper into his legacy and explore the lasting impact of his ideas.
I think you'll find it quite fascinating. He might have lived in the 17th century,
Mm-hmm.
but his influence continues to resonate today.
We've spent this deep dive exploring the life and work of Pierre de Fermat.
From his famous last theorem
Right, to his less known but equally impactful contributions.
to fields like probability and optics.
What strikes me about Fermat
Yes,
is that he embodies the spirit of a true polymath.
absolutely.
Someone whose curiosity and intellectual pursuits, they transcend disciplinary boundaries.
They really do. It's easy to get caught up in the specific theorems and problems he tackled. But what's even more fascinating is the bigger picture. What does Fermat's story tell us about the nature of scientific discovery?
And the evolution of mathematical thought.
I think one key takeaway is that groundbreaking ideas can emerge from unexpected places.
Yeah, Fermat wasn't a professional mathematician.
No.
He was a lawyer with a deep passion for numbers.
A hobbyist, really.
He didn't have access to the sophisticated tools and resources we have today.
Not at all.
Yet he made discoveries that continue to shape mathematics and science centuries later.
It's incredible.
It's a powerful reminder that intellectual curiosity and the pursuit of knowledge for its own sake
Yes.
can lead to remarkable breakthroughs.
Regardless of one's background or profession, Fermat's story democratizes the process of discovery.
Absolutely. And it highlights the importance of nurturing a mindset of inquiry and exploration
Of always asking questions.
and seeking deeper understanding. Another crucial lesson we can glean from Fermat's life
Oh, yeah.
is the importance of clarity and collaboration.
Yes, in scientific endeavors.
You're referring to his tendency to be secretive about his methods,
Right.
often stating his results without providing detailed proofs.
Precisely. While his intuition and insights were brilliant,
Right.
his reluctance to fully document his work
Okay.
and engage in open dialogue with his peers
Uh-huh.
sometimes hindered his legacy. It's a reminder that sharing our discoveries, clearly communicating our ideas,
Yeah.
and collaborating with others
Right.
is essential for advancing knowledge.
It's like he was playing a brilliant game of chess, but refusing to share his winning strategy.
Oh, that's a good analogy.
It's fascinating to consider how different his story might have been if he had embraced a more collaborative approach.
A good question.
Would his ideas have gained wider acceptance sooner?
Maybe.
Would his work have inspired even more breakthroughs?
Possibly.
We can only speculate.
Those are intriguing questions. It highlights the delicate balance between individual brilliance and the collective effort.
Right.
That drives scientific progress. Fermat's story serves as both an inspiration and a cautionary tale.
While his genius is undeniable,
It is.
his approach also reveals the potential pitfalls of working in isolation.
Very true.
It's a valuable lesson for anyone pursuing intellectual or creative endeavors. The lone genius myth can be alluring.
Oh, for sure.
But true progress often requires open dialogue
Feedback.
and the willingness to build upon the work of others.
Now, despite these missed opportunities for greater collaboration, Fermat's impact on mathematics is undeniable. His work laid the foundation for entire branches of mathematics, and his ideas continue to resonate with mathematicians and scientists today.
What would you say is his most enduring legacy?
I think it's his role as a bridge builder.
Yeah.
He connected seemingly disparate areas of mathematics, bridging the gap between ancient Greek traditions and the emergence of modern mathematical thought.
Yeah.
He demonstrated that the abstract concepts can have practical applications, linking number theory to cryptography.
Centuries before the digital age.
Centuries. And perhaps most importantly, he showed us that even seemingly impossible problems
Right.
can be solved with enough persistence, ingenuity.
And a deep love for the beauty and power of mathematics.
That's it.
So the next time we find ourselves grappling with a challenging problem, whether it's in our professional lives
Or personal pursuits.
or just a tricky Sudoku puzzle, we can channel our inner Fermat.
Embrace the challenge. Seek out patterns. Question assumptions. And never underestimate the power of a curious mind.
And who knows, maybe you'll uncover a hidden connection
Or spark an idea.
that will have a ripple effect for generations to come.
And on that note,
It's time to wrap up our deep dive into the world of Pierre de Fermat.
he might not have been perfect.
But his passion for mathematics, his unwavering curiosity, and his remarkable insights have left an indelible mark on the world. He showed us that the pursuit of knowledge is a journey worth taking.
Even if the path is unconventional and the destination uncertain.
Until next time, keep exploring, keep questioning, and keep diving deep.